Alright, so we're in a new unit, trigonometric equations. This is unit 7. We got a new table of contents. Please make sure that it looks like so. Alright, so basic trigonometric equations. Today we're going to learn about a few basic identities and how to use them to simplify as well as evaluate functions. Now, equation is an identity if the equation is true no matter what values are plugged in for the variable. That's what makes something an identity. Okay, that's what makes something an identity. And pretty much that's the bulk of your notes. Okay, everything else from here is going to be examples. You're going to learn about the different types of identities that we have that you'll need to know, and basically how to use them to evaluate functions as well as to simplify them. So this is your foldable. You're going to cut it out. You're going to fold it in like an accordion type fashion, and you're going to label the bottom ticket area basic trigonometric identities. And then right above that, these are your reciprocal identities. These you will need to know. Okay? But we kind of already know these already. Sine is the reciprocal of cosecant. Cosecant is the reciprocal of sine. So sine theta equals 1 over cosecant theta. Cosecant theta equals 1 over sine theta, and so on and so forth. You have your quotient identities, where you have tangent theta equals sine theta over cosine theta, and then cotangent, which is nothing but the reciprocal of tangent, which is cosine theta over sine theta. We're going to use these examples. We're going to look at these examples to solve these 4 different problems here. So cosecant theta equals 7 over 4. We have to find sine theta. Remember, sine theta is nothing but the reciprocal of cosecant. So since we're already given cosecant, that is 1 over 7/4. Well, you keep change flip here. And so sine theta is equal to 4 over 7. Simple as that. You use your basic identities to find that out. Now here, this one's a little bit more involved. You have cotangent x equals 2 over 5 root 5, and sine x equals root 5 over 3. You have to find cosine x. Now, with these type of problems, what is a little bit more involved, you have to think, how do cotangent, sine, as well as cosine all relate to each other? Well, hopefully you're able to say that, hey, using the quotient identity, cotangent x is equal to cosine x over sine x. From there, you can pretty much plug in what you have. You know cotangent is 2 over 5 root 5. We know that sine is root 5 over 3. Oops. Coming back right. We're looking for cosine, so we'll put that at the top. And then we know that sine is square root of 5 over 3. So all we need to do is basically solve for cosine x. Instead of keep changing and flipping this fraction over here to our right, you can do a shortcut basically by just multiplying the 2, 5 root 5, 5 root 5 over 3. So then that is hopefully you see that the root 5's cancel out, and then you just multiply straight across. When you cancel this root 5 out here, that turns into a 1, so that would be 2 over 15. I don't know what that was over there. Sorry, 2 over 15. Alright, now we have cosecant theta equals 5 over 3. You have to find cosine theta. Well, secant and cosine, they are reciprocals of each other, so cosine is nothing but the reciprocal of secant, which means all we have to do is flip it, and that will be 3 over 5. Basically, we're just using the identities to evaluate these problems. Lastly, we have cosecant theta equals 25 over 7 and secant theta equals 25 over 24. We have to find tangent. How do cosecant and secant relate to tangent? Hopefully you're able to recognize that cosecant is nothing but the reciprocal of sine, and secant is the reciprocal of cosine. So going to a new page just so I can have a little bit of space. Since cosecant theta equals 25 over 7, I believe. Yes, 25 over 7. that means that sine is just going to be the flip of that, which is 7 over 25. And since secant is 25 over 24, then we know that cosine is nothing but the flip of that, which is 24 over 25. A little bit of work that would need to be done to help us figure out what tangent is. Tangent is sine over cosine. Simplify that fraction, keep change flip. The 25s cancel out, and your answer is going to be 7 over 24. All right, so going back to your foldable, write up those reciprocal identities. You need to write down these Pythagorean identities. These two you will need to know, but there is actually a shortcut to remembering the bottom two Pythagorean identities. The first one is the main one. This is the basic one. This is that ax squared, not ax squared, I'm sorry, a squared plus b squared equals c squared. Pythagorean identities come from Pythagorean theorem, okay? We know that that's, okay? But when you look at your unit circle, okay, and we draw in a triangle, like we always do, okay? Technically, we would have a squared plus b squared equals c squared. Well, this c represents the radius of the unit circle. What's the radius of the unit circle?
1.
Exactly, it's 1. So c is going to be 1, so you squared that. And then your a and your b represent basically this x value and this y value. Now, in your unit circle, x relates to sine or cosine? Cosine. Y relates to what? Sine. So, if you plug these into your Pythagorean theorem, you will have a cosine squared x, or cosine x squared plus sine x squared equals 1 squared, which is the Pythagorean identity. Now, these two things mean the exact same thing. Cosine x squared is the same thing as saying cosine squared x. The one thing, though, is that you usually don't write it like this very first way because a lot of students tend to square the x. They tend to square the angle. And you don't want to do that. You're going to take the cosine of the angle, get whatever value that is, and then you square it. That's why you see the square written in between the cosine and the x, because you're squaring the entire cosine function. Okay? So, the other two, though, come about by doing a little bit of algebraic manipulation. If I take the very first identity, that sine squared theta plus cosine squared theta equals 1, and I divided every single term by sine, sine squared divided by sine squared is a 1. Cosine squared over sine squared would give you cotangent, except instead of being just a regular cotangent, it's going to be cotangent squared because your terms were being squared. And lastly, 1 over sine
But I'm gonna show up.
is the reciprocal of cosecant. And so there you go. You have that bottom identity. Cotangent squared theta plus 1 equals cosecant squared theta. So you can actually recreate that bottom and that middle equation just by dividing each term by sine as well as each term by cosine. So if I divided every single term by cosine squared x, sine squared x over cosine squared x is tangent squared x. Cosine x over cosine x is a 1, and then 1 over cosine squared x is a secant squared x. So really and truly, you don't need to know all three, you just need to know the first one and how to recreate the other two. So we're going to use these identities to evaluate, okay? So we have tangent theta equals -8, and sine is greater than 0. Find sine and cosine. Now with these, they're kind of similar to those problems that we did right before the midterm, okay? In the sense that they give you two stipulations and you have to find some of the trig functions. Now, if sine is greater than 0, that means your whatever value you get for sine has to be positive. But tangent is negative, which basically lets you know that in order for tangent to be negative, either sine or cosine are going to have to be negative. And since sine is already positive by that stipulation over here, we know that cosine is going to end up being negative. Okay? So your signs do matter. Be very careful with that. Now, in order to figure out what sine is and what cosine is, you're going to have to use the tangent theta equals -8 to go about doing that. And what you can do is you can use your Pythagorean identities along with your reciprocal and other ones to help you find sine. Now we do have an identity that says tangent squared theta plus 1 equals secant squared theta. So since we know that tangent theta equals -8, we're going to plug that in, and then we're going to square -8. We'll add 1, and we'll set that equal to secant squared theta. Now -8 squared is 64, plus 1 is 65. And in order to get it just being a regular secant and not a secant squared theta, we have to take the square root of both sides. And remember, whenever you take the square root of a number, it's always plus or minus. But remember, secant is the reciprocal of cosine. And so whatever cosine is, secant is as well, sine-wise I mean. So because cosine is negative, that means that secant is going to be negative. And speaking of the fact that they're reciprocals of each other, since secant is the reciprocal of cosine, we can use this to find out that cosine is nothing but 1 over -1 over the square root of 65, because it's the reciprocal of secant. Now you know we cannot have a radical in the denominator, so we rationalize. So it's going to be a negative square root of 65 over 65, and that is what cosine theta is equal to. Okay? Now to find sine, I'll hold off on this one. I'm going to do sine right below. To find sine, we can still use the fact that we know that tangent is -8, and cosine theta equals negative square root 65 over 65 to help us find sine. We could use the Pythagorean identity of sine squared theta plus cosine squared theta equals 1. We can do a couple of different ways, okay? Don't think there's one set way to actually evaluate a trig function. But what I'm going to use the quotient identity, which is sine theta over cosine theta. I'm going to plug in the fact that I know tangent is -8 and that cosine is -root 65 over 65. And just like before, I want to do that shortcut trick, which I'm basically going to multiply -8, and -root 65 over 65 to get my sine. Two negatives make a positive. Remember, sine had to be greater than 0. So sine is 8 squared root of 65 over 65. That's the same answer that you would get if you use the other Pythagorean identity or if you did it some other type of way. Now for that last one that I crossed out, I just needed the space. I'm going to do it on a new screen. I'm looking for cosecant theta and tangent theta. I know the cotangent is -3 and cosine theta has to be less than 0. Cosine is negative. And I'm looking for cosecant theta and tangent theta. Okay? So I can use any of my identities to try to figure this out. Now, since I am looking for tangent is nothing but the reciprocal of cotangent. So that was actually an easy one. I just flipped that. That's going to be a -1/3. And I'm done with that one. But to find identity that says cotangent squared theta plus 1 equals cosecant squared theta. Since cotangent is -3, I plug that in and I square it. -3 squared is 9, plus 1 is 10. So then cosecant theta, once I take the square root, is going to be a plus or minus 10, square root of 10.
Any and all students on campus that are both.
Okay, now you have to decide whether or not it's going to be a positive square root of 10 or a negative square root of 10. Well, since cosine is already negative because of the stipulation and cotangent is negative, that means that sine has to be positive in order for it to be a negative cotangent. Okay? And since sine is the reciprocal of cosecant, that means that cosecant is going to be a positive square root of 10. Okay? Which means that sine, since it's the reciprocal, is 1 over the square root of 10, or rationalized square root of 10 over 10. And I know you're like, wait, we still are looking for cosine. Fully aware, okay? But now that we have cotangent and sine, we can use the fact that cotangent theta equals cosine over sine.
Okay.
Sorry guys, I went a little bit ahead. I guess I was looking at this thing and I had to find cosine, but I actually just need to find cosecant, which I found back here, which is the square root of 10. I do apologize. Ignore this part over here. Well, not the sine theta. It's positive. That's important. Put everything below it. Okay? You guys are doing problems 1 through 6. One more example. Okay. Yes, you guys are going to do this one on your own. You're doing problems 1 through 6 on the homework, only 1 through 6, and this problem. Do this one on your own, and bring any questions you guys have to class the next time I see you.